Hello, everyone. So we're just going to have our final speaker before lunch. So I'd like to welcome Dr. George from Obrela, and he's going to talk to you about transformation of SOCs. Thank you.
Hello, everyone. Welcome to my presentation on transform distributed SOCs into a virtual resilience operation center. A global MDR service provider usually operates distributed security operation centers across various regions, aligned with their strategic plans. Although each SOC entity may have its dedicated team and adheres to standardized processes and procedures to maintain uniformity in operations, instant response and reporting, the decentralized structure of operations introduces different challenges. We're going to discuss about these challenges today. The provider can tackle these challenges by emphasizing to resilience. Resilience embraces a wider perspective of readiness and adaptability, introducing the need for a new operating model. So during this presentation, I will present the essential components that such providers can integrate into their governance frameworks to facilitate the transition of regional SOCs, distributed SOCs, into a virtual resilience operation center, or ROC. I will highlight certain enhancements we propose based on our experience in Obrela to achieve this. So, distributed security operation centers. The mission of a global service provider is to deliver their services worldwide. Operating distributed SOCs is a key component of their objectives. So, a well-functioning SOC effectively integrates the aspects of people, process, and technology. Processes to provide structured methods and guidelines for consistent and efficient operations. You can see some examples in the screen, such as threat hunting, threat intelligence, risk management, operations, and content development. People to use the right skills and expertise to monitor, detect, and respond to threats. And the skill set is continuously expanding to include not only threat detection analysts, but also engineers, data onboarding and threat detection engineers, but also DevOps and customer success managers. Technology equips the SOC with the necessary tools to provide state-of-the-art MDR operations, utilizing a mix of XDR and CM technologies to handle the increasing volume and complexity of cyber threats. So, quite reasonably, then the distributed SOCs emphasize to having the right capacity of security experts to be able autonomously to perform threat detection in an optimal way with the support of detection engineers, handle alerts with minimum false positives and false negatives with the support of security analysts and investigation experts, respond fast on high criticality cases with the support of incident responders. However, is it possible a DSOC to deliver equally high quality, reliable, and professional services no matter its operating model? A distributed SOC can be a regional, a follow-the-sun, or a remote SOC model. Dynamic allocation of resources and the collaboration between these SOCs to optimally contribute to one another is another challenge. So, collaboration between distributed teams requires coordination, workflows, and procedures, taking into account the type of SOC, the operating model per se, and time zones. Information sharing practices to support collaboration in a structured or ad hoc basis is vital, as well as the coordination protocol of doing handover of incidents or alerts from one team to another. However, miscommunication due to language differences, can lead to delayed incident responses or incorrect actions. Different cultures may have varying perceptions of risk, which can influence how threats are prioritized and finally handled. Time zone differences can complicate coordination and response times. Operating in multiple regions with different regulatory requirements can complicate compliance efforts. At the same time, continuous improvement can be achieved via regular assessments, audits, internal or external, and drills. However, an assessment framework for distributed security operation centers may not exist. A culture of innovation and agility to respond effectively to emerging threats and changing business needs is important, and the potential of generative AI to support corresponding tasks is promising. However, a framework of protecting data access and consolidation of the generated information does not exist yet. We saw that in the previous presentation of Nikos and Fanis. A lack of agility can leave SOCs ill-prepared to handle complex cyber attacks. This may introduce higher operational costs due to uneven distribution of workload between SOC teams, or higher levels of stress and burnout among staff, leading to lower morale and higher turnover rates. Now, as you can see in the graphs, uneven workload between the distributed teams can arise from a combination of multiple factors. These factors can be related to the organizational characteristics of the customers in each region, industry-specific challenges, monitoring infrastructure differences, and the maturity of the security practices to each region. On the other hand, the skill level and experience of SOC analysts can significantly impact the overall team performance. In the first graph, you can see the first team who are at a burnout stage, and the second team is underutilized. And at the same time, the first team is also spending more time on handling incidents. So, as you can imagine, a regional SOC, which is experiencing staff challenges, alert fatigue, or maturity deficiencies, find difficulties to help their assigned customers to withstand and recover from adverse events. Reaction time is the main KPI that customers evaluate in a SOC service. And we have seen this to other industries as well. So we need a new model, the model of a resilience operation center. A global MDR service provider can tackle these challenges by emphasizing to resilience. The key is the following. The service provider as a whole must possess the capability to adapt and safeguard the customer's business anywhere in the world. This introduces the concept of a virtual resilience operation center and sets as primary objective to transform the existing SOCs into a virtually unified operation center. What is the mission of a ROC? The mission is to be able to have a centralized understanding of the global status of the threats across the customer portfolio and be able to react fast and independently of the region. Adapt the concept of real-time risk management by emphasizing to collective threat intelligence, correlation of risk analytics, to prioritize risks in a smart way, and mitigate first those which are posing threats for serious damage. Provision continuous and uninterrupted operations across these SOCs by dynamically moving resources when and where needed. The governance framework of a ROC can include operational workflows, controls and measures necessary to guarantee the efficient operation of a unified service. And this framework includes SOC operations of the distributed teams, threat detection engineering and support of the blue teams, centralized threat hunting and incident response teams, whereas the business continuity plans ensure that each of the aforementioned teams are trained to contribute to the minimum mission of a ROC, monitoring and alert handling. SOCs use KPIs to measure monitoring effectiveness, set up feedback loops between analysts, and establish collaboration procedures for knowledge sharing, while at the same time focus to retraining. They use quality controls to eliminate human factor mistakes and focus to the development of the analysts as well as the rest of the teams. The blue team support the detection engineering team, ensure adequate content of security analytics, use KPIs to evaluate monitoring coverage and tuning. The CSIRT teams contribute proactively to alert handling and incident response, but also help the customers through proactively, again, tabletop exercises and assessment of forensic readiness. ROCs need to invest in tools of SOAR capabilities, tools which achieve synchronization of MDR and threat intelligence capabilities across locations for orchestrated investigation and response. For example, SOC streams, part of Obrela's service delivery platform called Swordfish, provide SOC teams with centralized visibility into security data of multiple customers in multiple regions and actionable insights into the incoming alerts, in real time, of course. Security analysts can work from one pane of glass to quickly understand the security posture of the customers, identify the most critical threats, and drill down to get more details, helping to streamline the investigation and response workflows. The platform eliminates the need to pivot between tools. On top of SOCstream's SOAR capabilities, and as part of ongoing work in Obrela, we have been enhancing the alert management mechanisms of SOCstreams to optimize the alert prioritization and support dynamic assignment of alerts to analysts. So the embedment of a machine learning-driven alert prioritization mechanism allows the analyst's attention to the right customers, the right alerts and risks, so that they proceed to handle them in priority. Moreover, we have built quality assurance mechanisms to guarantee the addressing of all evolving threats while helping SOC teams to self-improve on or share lessons learned on incident handling. So in the previous diagram that we could show a gap between the performance of two SOCs, by applying this mechanism, now we can see that this gap is closing. Risk analytics is a valuable asset in Swordfish and are used to provide risk indicators on alerts, taking into account historical data, for example, number of occurrences of the alerts in the same customer environment or across environments, the mapping of the alerts in the MITRE framework so that we can evaluate the impact, the associated CIS controls of the corresponding standard at risk, known vulnerabilities on the affected hosts, the status of the attack surface and exposure of the organization. This helps to shorten the triage time that the analysts require on alerts processing, and at the same time provide specific metric data to any collaboration with other teams. Remember the language issue that I mentioned earlier. So, as previously mentioned, a set of quality assurance controls empower the continuous monitoring and agility, improvement and agility of the service in a unified way. They support enhancement with KPIs for continuous monitoring of readiness across locations and dynamic augmentation of capacity of specific roles when and where needed. We adopt a human factors approach. We call it skills, rules, and knowledge approach, inheriting lessons learned from other industries, which are also heavily relying to human factors. At the same time, this mechanism paves the way for forthcoming automations, utilization of LLM, and AI-based co-pilot models in the near future. Based on the skill, rules, and knowledge evaluation approach, we have built early feedback mechanisms to guarantee the addressing of all evolving threats across SOCs while helping their teams to self-improve. The diagram is just a sample of continuous QA monitoring procedure in which a set of quality checks take place in each SOC or across SOCs to ensure that all alerts that were raised in the SOC shifts have been handled, perform backtracking checks to alerts associated to high-risk indicators, but were not initially escalated to the customers, and ensure that all incident reports have been escalated to the customers to the right severity level, description, and recommendation actions. So, in this presentation, I try to highlight the need for service providers to focus to a new perspective as part of the service management framework of these providers, which embraces resilience. I highlighted examples of components, strategies, and tactics that such providers must incorporate to facilitate the transition of regional, remote, or other types of distributed SOCs into a virtually unified ROC. I try to share our experience in Obrela from running regional SOCs and how we managed to transform them into a unified operating model. Thank you.